Hello and welcome to the Slackware ARM YouTube channel. I'm Stuart Winter, the platform architect of the ARM port of the Slackware Linux distribution. And with me we have Phil, who is the maintainer and developer of the SAPI project, which is a set of tools and documentation and support to get Slackware ARM onto Raspberry Pis. Hi Phil.
Hi Stuart.
How are you?
I'm very well, thank you. How's yourself?
I'm pretty good. I'm looking forward to today's video because in this one we're going to be testing the latest Linux kernel, which is the 5.10 series, which is going to be what makes it into Slackware 15. I've been soak testing it on the Orange Pis already, but I haven't tested it on the other two platforms that are officially supported, which is the Banana Pi and the Trim Slice. Today we're going to go through and test that kernel on the Banana Pi because that's the one I happen to have on the desk in front of me that I've got access to. So I'm kind of all ready to go. Have you got any questions from last time we spoke or anything?
And I went off and had a look at some other videos relating to Slackware. Mm-hmm. And what I'm finding is quite a lot of people, because there's the stable version and the current version, a lot of people are referring to the current version as a beta unstable version. Now, I have never regarded current as unstable, and I didn't actually know whether or not it was a beta. So could you enlighten me on that?
When something's marked as beta or it's marked as a release candidate, what the developers are telling you is that we're almost ready to go with this. Please test it and report back issues as fast as you can. That's what beta really means. It means that the thing is almost ready to go. It also comes with a few caveats. You know, there might be something in the notes for it that says we know about these certain bugs, we're working on them, so ignore those but test these things. Slackware current by default is not beta. It's not in a beta state until it says that it is in the changelog. That's when it becomes beta. So what Slackware current is, Slackware is not a rolling release model. It has stable release markers throughout its timelines. Those are versioned. As of January 2021, the latest version is Slackware 14.2, and the next release will be Slackware 15. Slackware current is the journey from the point at which the last release was completed and stamped and pushed out. Slackware current is the what you're watching now is the evolution of the operating system, of the distribution. In terms of stability, it can be unstable at times because the current development stream is the place where you introduce instability. It's the place where you test things. However, that said, I know that Patrick makes every effort, and so do I for the ARM port, to make it so that when changes are pushed out, everything is pushed out together that works. You know, whether you use Slack package or you do it manually or some other tool to consume those updates and install them on your Slackware operating system, every effort is made so that when you do consume the updates and you do follow any instructions you need to in order to migrate from one thing to another, the system should be stable. Okay, it doesn't mean that it always will be. Of course, there will be problems in there. It's just the way it works. But that is the point of that. But generally, I mean, I used to run Slackware current at an ISP when I worked there because there were a couple of machines I wanted the latest versions of something in particular because I was working on something. But for example, the machines, all the Slackware servers I ever installed and managed, they all ran the latest version of the stable release of Slackware because in my case, I was building and maintaining a web platform. So when people would upload, say, their PHP scripts, they expected it to work with PHP 4 or whatever the version was at the time. And if you go and change that environment across the board and don't provide individual versions of things like PHP and other types of languages and tools and libraries and stuff, you'll break things. So my home gateway that runs Slackware ARM, that runs Slackware ARM 14.2. My desktop machine that I do my Slackware development on runs Slackware 14.2, x86-64. The machine that I'm running this YouTube channel on is Slackware 64 current as of, in fact, today. I only installed it today. So it's got the latest version of KDE and everything on it, and it works perfectly fine. So generally, Slackware current is going to work pretty fine. You usually won't have any issues with it. But if you do look at, say, Linux Questions Forum, which is the official Slackware support forum and community, then you will of course see people that have certain issues with kernels, certain issues with packages and things like that. That's to be expected. But I think for the most part, it works. It's very stable, in fact. But again, to me, it's really about how you want to manage it. I don't want to be constantly upgrading my servers and constantly updating packages. If I, actually, it's funny you should ask, because I've been thinking about this when I get the Pinebook Pro for the ARch64 port, because that will be running current for a long time. Because it's my distribution, I'm prepared to be, I'm going to be updating it as we go along. But I wouldn't want that on my laptop, because I'm not, for my use case, I just want a stable machine that I can just do my work on and just update the security patches and things like that. So it depends what you want to do. If you want to go on the current branch, you just need to be aware that you may have to recompile third-party packages, for example, when we upgrade major libraries or remove certain packages or something like that. But for me, Slackware Current is very stable in general.
I can't remember how many years I've been using Current for. I've encountered one problem, and that, I'm guessing 5-6 years. I've only ever come across one issue that needed addressing. So, when people on these videos that I've seen say it's the unstable version, I think that's quite misleading. It might be the in development port of Slackware, but it's by no means unstable.
Yeah, it depends what you mean by unstable, because that's quite a loaded word. It doesn't mean necessarily, to me at least, it doesn't mean that the system's going to just crash at random. Linux, I don't know, in the last, 15 years or so, it hardly ever crashes. Sometimes, for example, you'll get kernel panics on certain modules. Like me, you're testing certain things and adding them in. Sometimes that happens, but generally, the systems are pretty stable. The software these days, the core components are pretty stable. But I mean, Slackware doesn't use this term unstable. Debian does, for example. They have an entire distribution stream called unstable. I haven't looked at how Debian define it, but it could also mean that the library versions are unstable. So if you're introducing a major library change, and so that the package needs to be recompiled. So that could also mean what they mean by unstable. Like, you'll upgrade it and your own packages that you built no longer work. But the packages that Slackware supplies work fine. That's one of the reasons why when you see updates in Slackware, you often see a lot of rebuilds. And sometimes there are notes about why it's been rebuilt. Often that's simply to accommodate the upgrade of a major library. It could mean unstable in that way. But in terms of, using a system that's suddenly panicking, it does happen to some people, but I think it's hardly ever happened to me. But again, to me, it really depends on what you're looking for. In the case of Slackware ARM hardware floating point port right now, there is no release of it. There is no stable release of the hardware floating point port, because there has been no release of Slackware since I started the hardware floating point port. So you have no choice but to use current if you want to use a hardware floating point version of Slackware ARM. But once Slackware 15 is released, I mean, I will be upgrading my home gateway server that runs, the software floating point version of 14.2. I'll be putting 15.0 on there because it's an ARM v7 machine that can accommodate the hardware floating point port. That server will then consume these security and update packages from the Slackware 15 tree. So, okay. Yeah, I think it just depends what you're looking for, and you just need to be aware of what you're getting yourself into.
Thanks for answering that. It's cleared up a lot of queries.
No worries. Well, that's a good segue into what we're going to be doing today, which is testing the kernel before we put it out. So what I've been working on is merging in what Patrick called the big merge. Hundreds of packages have been upgraded and added in the Slackware operating system environment. We've also done major upgrades for KDE and XFCE. I have been putting off pushing anything out because Slackware x86 is also now on the Linux 5.10 branch, which is the long-time service branch. That'll be the kernel release that makes it into Slackware 15. I have been soak testing the new Linux kernel on my Orange Pis because those are the two main hardware platforms that I developed Slackware ARM on, but I've yet to test it on the Banana Pi or the Trim Slice. So I'm soak testing the kernel on the other two machines, and the packages are building over and over. So I'm pretty confident the kernel's fine. I've not seen a single problem with it so far. Did a make old config, assembled the list of patches, updated that stuff, rebooted into it, just worked fine. So I've been really, really happy with that. I mean, Linux has come a long way, because before Linux 5.4, there were always some problem with the kernel. It would a kernel panic, or I'd have the wrong module somewhere, but it just works. The way I test minor releases, point releases, is I just reboot into the kernel, because I always have at least 2 Slackware ARM machines running. So if one of them gets broken, I can recompile the kernel, fix it on the other one, and then boot the other one again over the network. What I'm going to do here, test the kernel on the Banana Pi by booting into the installer. Whenever the kernel is built, the installer is also respun, because the installer always has to match the current kernel. So let's do that. So the first thing I'm going to do, I'm on one of my Slackware machines, and I'm in the Slackware ARM current directory tree, and I'm inside the install docs. So let's have a look here. So install the Banana Pi is an all-winner A20. So these are the installation documents to install Slackware ARM onto that device. Now, you can see they're pretty text heavy. I mean, I've kind of extensively documented all of this stuff. But as you'll see right now in this video, to actually use this is pretty straightforward. And the reason why, in fact, it is a text file and not in a wiki document is because I can easily just copy paste from this document, because it's in a shell window, it just works. So you'll see me doing that. In order to install Slackware ARM on the Banana Pi or any of the other devices that I support, you do actually have to read the documents, and you have to do a little bit of local setup. The way I have documented it, which is how I actually use the system and the way I install it, is to do it over the network. It's just the easiest way for me. But then again, I also do have all the server set up for this stuff. So there are other ways of installing it, but this is the way I do it, and it's the way I've documented it. So I've already set up my environment, so I don't need to set up a TFTP server. I don't need to populate the TFTP boot directory, because my install build scripts do all of that for me anyway. The only thing you'll see here, though, is that this percentage slack tree %, what is that? Well, in, I think, episode 2 of this video series, you saw me pushing out the Slackware ARM 14.2 updates. And part of the system that does that substitutes this here with the actual version of the Slackware tree. What that allows me to do is to have the same documentation file and never have to remember to actually go and update it. So, for example, I wouldn't push out this documentation with Slackware current in it if it was for 15.0. My scripts would automatically just adjust it to 15.0 or 14.2 or whatever the distribution is. It just saves me a little bit of work. As I said in the second episode, there are 2 trees here. This is the Slackware ARM master tree, and then we have the Slackware ARM public tree. So I'm going to have a look at the Slackware ARM public tree just to make it a little bit easier. Okay, oops, install A20. Now this version is the public version, so you should see, I hope, in it that, okay, there we go, yeah, exactly. So this is Slackware ARM current, and now you can see that everything has been replaced with Slackware ARM current. So that's all taken care of. So we don't need to do any of this stuff. We just need 2 things. We need this line here, which is going to open up the serial console on my Slackware x86 machine, which is the Banana Pi is physically connected to on the serial bus. Let's do that first. I've now opened a shell on my x86-64 Slackware box, which is where I do the development and that kind of thing. And let's run dmessage. So we're going to print out the kernel ring buffer, and the driver for the particular serial cable I have, which is the PL2303, that's showing that it's connected to TTY USB 1. But if you look at my documentation, you'll see that it expects TTY USB 0. That's simply because on the same USB bus, I have the Orange Pi. So I've got my Orange Pi connected to the same machine. So that is currently occupying TTY USB 0. It's quite a good example, actually, because if you do have multiple ARM devices and you want to use a serial, you need to be aware of that type of thing. So we can just have a quick look as well. If we look at, say, I always use Screen because it's one of my favorite tools, and you can also use it to open serial consoles with. So we should see here that indeed There's screen, it's running USB 0, TTY USB 0. And if I do screen-rd, there is Mojo, which is an Orange Pi, a quad-core Orange Pi. Here, the TTYS 0, so it's showing me is coming into the server via a serial console. And as you can see, I am actually testing KDE5 on this machine right now. All right, let's just change that to TTY USB 1. See what we have here. Platino login. So that Platino is the name that I gave the Banana Pi that's on my desk. It used to be one of the primary builders for Slackware ARM until I got the Orange Pi, which is faster. So as you can see, this has got Linux 5.4.2 on it. So I think the last time I actually booted this Banana Pi was to test the previous major release of the kernel. So let's reboot this machine here, and we'll just do a force reboot. I'm not going to do a graceful shutdown because there's no point. I'm going to blow the machine's file system away, so I'm not too bothered about corrupting anything. Let's just reboot into U-boot. So what you see here is the U-boot console. U-boot's the main bootloader that's used on the ARM platforms. So it gives you a little bit of information here about the device, how much RAM it's got. As you can see, it's only got 1 gig. The Orange Pi has 2, which is also one of the other reasons why I switched over to it. And we've got the environment. It's loading the boot environment from FAT, which is stored on the SD card. So the U-boot itself, the way I do Slackware ARM, and I'm trying to see if I can do this for AArch64 as well, actually. I haven't got there yet, but I've been thinking about it. The way I do this is that I build U-boot and I put it on an SD card. The machine it'll load U-boot from the SD card. And the reason why that's important is because back when I showed you the Shiva plugs, and I gave you a little build tour of the Shiva plug for Slackware ARM 14.2. The thing about the Shiva plug is that you also needed to upgrade U-boot. You know, there were new versions coming out, and some of them were a little bit flaky with USB and stuff like that. So you upgraded U-boot on it, you had to write it to the flash. If your U-boot didn't work, the device was bricked, and it was pretty hard to recover from it. And then the trim slice came along and said, well, they learned those lessons, and they made their trim slice boots from flash, but if it wouldn't boot from there, it booted from an SD card, or you know, the order was switched around or something. I can't remember. I got the idea that was a pretty good idea, and so since then I tend not to do anything. If there's a U-boot on the flash, I just leave the factory version typically, not always, but most of the time. And so in this case, U-boot's loading from the SD card. Now, when it boots, you have to hit the return key, just hold it down. And when you hold it down, that allows you to abort the boot sequence. So you can see it says hit any key to stop the auto boot. So you just keep pressing return. Okay, so we're now at the U-boot console. We need to boot the installer. The way I do it normally is I actually have a little script that I just copy and paste it, and it just boots it, and it's pretty fast. For the sake of this video, I'm going to follow the installation documents. Back on the installation documents. So we've got the serial console open. We can move on. I don't need to do any of this stuff right now because my Banana Pi has already been configured. I've already copied all of this stuff in. And literally what I do when I set up the machine and when you install Slackware ARM is I literally copy and paste this lot into the U-boot console directly. I don't change anything. So you can follow this installation and install it directly on a Banana Pi. And that's the same with any of the documentation. So we can skip down here and into the Slackware ARM installation section. Okay, so we're going to boot the installer. Now, in U-boot, there are a couple of shortcuts. You can just type DH. Okay, so as you can see, the machine now has an IP address. It's also downloaded this PXE Linux.0. That's because my TFTP server is configured to supply that automatically, I think. I can't remember, it's been a long, long time. That's for x86. It doesn't do anything here, so we can just ignore that. All right, let's paste that in. So what this actually is doing, this file here is not an init.id. It's not a kernel. It's actually a U-boot script. In the installation documents, what I've tried to do is minimize the amount of errors you could make by minimizing the amount of text you need to paste into or manually type into the U-boot terminal. So what this is actually doing is using TFTP to download a U-boot script into RAM like this. So it's like literally, 42K? It's not much. And then what that does is inside that script, it sets a whole bunch of settings. We're kind of going a little bit off-piste here, aren't we? from the original intent, but let's have a look at it anyway. I'm just going to show you that file. So just to see what's in here. Okay, so these is basically just a way of making things a little bit easier. So inside this directory here are a number of these pre-built U-boot scripts that are just simply starter scripts for the supported platform. Let's have a quick look at what this is. So we know we're looking for the Banana Pi. Let's just run. These are actually U-boot quote compiled scripts. So they've got a bit of U-boot binary gunk around them. So let's just run them through strings and see what's in there. Okay, so basically this is, as you can see, these are a whole bunch of U-boot commands. So you can imagine if I included all of this inside of the documentation, well, some of it is actually, but if you had to copy and paste all of this, that you'd probably get something wrong, particularly if you manually typed it in. So this is just a way of loading this script into RAM to save you the bother of doing all of this. We've loaded that script in. Go back to the documents here. So we've booted the script. Then we need to tell U-boot, like you do in Bash, you do source, which calls a Bash shell script and runs it. Boot that script. Let's go. So it's now going to boot the Z image, which is the kernel. It's now booting the Slackware installer, which, as you can see, is quite large. It's about 60 megabytes in size at this time. Sometimes when you boot it, you'll see T in the middle of these hashes, which means timeout. It just means it had a bit of a network blip. And typically it will continue after that. Okay, so the kernel has downloaded and now it's starting. Okay, this looks good so far. Okay. And there is the Slackware installer. Okay, and let's see what we've got here. Typically the build machines that I use follow exactly the documentation. So even the file system is exactly the same as it is in the documentation. Okay, all right, so there we are. By the way, if you don't know, you actually don't need to log in as root. It's just a shell command that just says read. So you can just press enter. It's just, maybe in the old days it really used the login tool. I don't know, I've never asked. But there we go. So there's a Slackware installer. Let's just see where we are. SDA, perfect. Okay, yeah, this is exactly as the documentation describes. So at this point, we've proved that the kernel boots. So that is a great start. There was nothing in the dmessage output that concerned me whatsoever. So let's get installing and see how we go. We're not going to do a full installation here. We can't wait. It does take over an hour to install. So we'll just set it going at this point. Now, in the Slackware ARM installer, there is a little script called QGO, which is not in the x86 installer. This is really for my benefit, no one else's. But the reason why it's in here is because it sets the terminal window like this, and it also updates the clock on the machine, because some of the ARM devices don't have real-time clocks. So you boot them and it's 1970, just like this one. So this sorts that out. You can just type setup as you would with Slackware normally, and that's in fact what this script does, but it also sets the clock as well. In addition, when the installer exits, the control will return to this QGO script. And because it's easier for me to have the machine boot on the network and be able to SSH into it from anywhere, you can see that my script actually switches the default permit root login to no, switches it to yes. So by default, Slackware ships with SSHD denying root logins, and I suggest you leave it that way. I never have a machine exposed to the internet, particularly where you can log in as root. It's just a really, really bad idea. But because these machines are only on the LAN, I'm quite happy to do that. So that's what goes on there. So I'm just for this, because it's easier, I'm just going to run the QGO script. And we are on, was it Platino, isn't it? So let's do that. So as you can see, the actual title bar has now changed to Slackware ARM installer and Platino. The reason why I do that is really straightforward. It's because the machine we're looking at here is not my regular desktop machine. This is a nice clean machine for the presentations. My actual desktop machine has so many windows, terminal windows everywhere. So this is a really convenient way for me to know which terminal is physically connected to what. So that's why I do it that way. Okay, so let's just quickly add a swap partition. We can do that just by clicking on there. So I'm actually, as you can see, moving the mouse pointer and actually clicking on it. Yeah, let's switch to the keys. I don't want to do that. Let's just configure some swap. Let's just format that. Let's just format it as ext4. That will just take a moment. Phil, how is this different from the Raspberry Pi? I mean, is it kind of similar in the way that it boots, or is it?
No.
Oh, okay.
There's two files: config text.txt and command cmd line.txt. And basically, the config.txt file contains all the settings that you specify for the system booting up. Things like the amount of shared memory between the GPU and the system, what interfaces you want to include, things like that. And the CMD line file is basically your command boot up parameters from the kernel.
Okay.
What I do is copy them directly from the kernel and put it in that file. So it really is not anything like U-boot at all. We've had many discussions in the past about U-boot, and this is the mystery of it. Your understanding of the way it works is far beyond mine.
I thought it was going to be slightly different. I know I've looked at it in the past, but I've never actually used it. All right. So the installer is now asking what I want to do with the FAT or NTFS partitions that it's found. The eMMC on the Banana Pi, I don't think I've touched it from the factory default, which is to have a FAT file system on it. So I am not interested in mounting those. Okay, so the way that we're going to install it is over NFS. That's the way I always do it. You could actually install it from a CD. I have actually installed Slackware ARM from a CD because I have one of those USB CD drives. So I just plugged it in one day to see if it worked. It worked fine. Okay, but let's install it over the network because that's where the stuff is. So we'll just give it my current Slackware. Okay, there we go. Awesome. Good. So it's mounted my server over NFS and we're ready to go. I'm going to install everything. That's what I always do. And we'll pick terse. And there we go. So the installer is now installing, and maybe in an hour or so, we'll have the system fully installed. It'll be back to asking me for a few post-installation configuration questions, just like the regular x86 Slackware installer does. And then we'll reboot into the environment, and that's it. So I'm pretty confident at this stage that the kernel is working fine. I mean, I can just quickly check it as well. We could just pause the installer by Control and Zing it, see if there's anything in dmessage. Well, that's nice. No, there isn't. There's nothing there. There's nothing popping up. But yeah, that's how I'm going to test the kernel on these devices. I reinstall the entire machine and leave it for a few days, run a few tests on it, and I'm happy that the kernel works. So we're done for this episode. Unless you've got any other questions, Phil, we'll call this one a day.
Yeah, it's the whole U-boot way of doing things is interesting. It's something I'm definitely going to look at. Looks complicated, but I'm sure once I've gained a basic understanding of how it works, it's not going to be that difficult at all.
The way I've documented it, you can literally just copy paste what I've done. I'm not a U-boot expert. I have looked at it extensively, but I'm not an expert in it. One of the good things about U-boot is that it's actually scriptable. Inside of U-boot, it has a scripting language. So that's pretty good.
Right.
Yeah, so you can, I did experiment with it a while back, well, many, many years ago, because I wanted to try and remove some of that complexity from the installation documents. I had a look at how Debian were doing it, and it was good, but it's just, the thing is with U-boot is that when the versions of U-boot changes as U-boot's developed, it could mean that I have to then start maintaining the tool that updates the U-boot config from within Linux. So what you saw me there was, the U-boot console directly, but you can, some versions of U-boot, modify the U-boot config from within Linux as long as it's accessible.
Yeah.
But the way I've got it works fine. And the thing is, once you've installed it and you've set up your machine how you want it, you're not going to be changing the U-boot config much, if at all, ever. I mean, I never touch it. So let's call this one a day. I hope that was interesting to everybody. If you liked it, please like and subscribe to videos, as everyone says. So that way, when we upload new videos, you'll know about it and you can watch them. If you've got any ideas and suggestions, let us know in the comments. But other than that, it's goodbye from me. I've been Stuart Winter and I will continue to be.
And very goodbye from me.